The product property of exponents shows us a shortcut for multiplying expressions with the same base. The base of an exponential expression is the number that you're multiplying that many times. So here the base is 5 and the exponent is 3. As long as I have the same base, then I can rewrite this problem this way. I'm just going to copy this times dot down, and I'm going to rewrite 5 to the third power, or 5 cubed, as 5 times itself 3 times. On the right hand side of this dot, I'm going to write 5 times itself 2 times. But the thing is, this is multiplication, and so is this. All of these operations are multiplication. So actually, I could write this in a shorthand, 5 to the power of 1, 2, 3, 4, 5 copies. 5 times itself 5 times. Since I'm taking these 3 copies and these 2 copies, and everything is multiplication, what ends up happening is that I can add my exponents. I'm adding this many copies to this many copies, but I'm multiplying all my copies. So the shorthand for a base to one power times the same base to another power is the base to the sum of the powers. Add the exponents. Remember that this really means multiplication. And this is multiplication too. So this many copies and this many more copies is this many copies. Let's do an example. 3 to the 8th times 3 to the 10th. Even individually, these would be hard to work out. 3 times 3 times 3 times 3, 8 times. And 3 times 3 times 3, 10 times. But at least I can find another way to write it. I can write it as that same base to the 8 plus 10. And that's 3 to the 18th power. If I had to write this all out, I would get 3 times itself 8 times from this piece. From this piece, I would get 3 times itself 10 times. But I'm supposed to be multiplying this by this. So let's multiply this by this. Now, every single dot that you see here, including this one, is a multiplication. So all I'm really doing is multiplying 3 by itself this many times. If you count these, you'll get 18. 8 and 10 more. Here's another example. X to the 7th times x to the 8th. Well, I could write that out as x times itself 7 times times x times itself 8 times, and what I'd end up with is a total of 7 and 8 more copies, or 15 copies. So without writing it out this time, I see that x to the 7th times x to the 8th is x to the 7 plus 8. This is the generic version of this property. Your textbook uses A instead of B. I've chosen to use B because I think it helps you to remember the terminology that goes with this. This is the base. This is the exponent. Why not use E for exponent? Well, if I used E for every exponent, that would imply that these were the same number. These are effectively variables. The value for B can change. The values for R and S can change. But B has to be the same in both cases, and R and S can be different. Okay, one more example. T to the 4th times t to the 8th times t to the 5th. Again, if I were multiplying together t times itself 4 times t times itself 8 times times t times itself 5 times, and then finding a way to write this in shorthand, if I counted 4 copies and 8 more copies, that would be 12 copies so far, and then another 5 copies is a total of 17 copies. Notice that when I do that, I could have got there just as easily by counting how many copies without actually writing them down. Add the exponents.